lecture.
Aba.
Okay. So, again, we're already done with our discussion on solid state chemistry, di ba? And for this session, we will now start answering the practice exercises. And may copy ka, no? May copy ka na ng mga practice exercises. Na-start mo na ba siya gawin or hindi pa? Or ngayon lang?
Nagawa na po.
Okay.
Sino yung pen?
Allow me to share first.
Saan yung pen? Lagi. Yung pen. Yes, wala. Yan, okay.
Okay. Kita mo yung screen? Yung
Opo.
slides? Okay.
Naka-slides po sila?
Yeah, actually, kinonvert ko sa, hindi naman, nilipat ko lang yung mga, nagkumuha lang ng screen cap and then I put it in a single slide for each question.
Opo.
Okay. So, ready?
Opo.
Okay.
Wait lang po, nakabaliktad po yung yung tablet. Para hindi ko mabukas. Ayan. Okay na po.
Okay. So, let's start with question number 1. Hindi mo na siya problem solving. So, for number 1, consider the following substances in their solid state. So, we assume that all the substances in the
Nag-freeze po.
classify them based on their type as a crystalline solid. Okay?
Opo.
So, for number 1, are you familiar with styrene?
Yung parang predecessor po ng styrofoam?
Yes. Actually, in polymer chemistry, we call that monomer. That's the monomeric unit of polystyrene. Yung polystyrene, siya yung common na material na ginagamit to produce styrofoam. Styrofoam, I think is a brand yata.
Opo.
I'm not sure kung brand siya or common term lang siya for the material. Okay, pero yung polymeric material is called polystyrene and the monomeric unit is what we call styrene. So, styrene is a type of what compound?
Aromatic po? Parang I'm just basing this over yung yung naalala ko po.
Actually, based on this context, what I'm looking for lang is that styrene is a molecular compound. Okay? Yun lang. On this context, styrene is a molecular compound. So, if it's a solid, what kind of solid crystalline material would it be?
Yun nga po, molecular. Wait lang po. Susunod ko lang po lahat.
Okay. So, for A,
And medyo hindi po ako sure dito, pero I don't know. Probably. Kasi, naman po siya eh. Ay, hindi
Okay,
pa.
sige.
Wrong question po. Ito po yung medyo po ko, so I will do that later po.
Kahit yung initial answer lang.
So, ito naman po,
Okay. Okay, for your answers, let's look at yung mga let's look at the first one. So first one is styrene. This is correct. Styrene is a molecular solid. Bronze, your answer is metallic. What is bronze?
Zinc plus copper po.
So it's an alloy of zinc and copper. Okay. So for this case, it is just a physical mixture of zinc and copper. Wala talagang chemical bonding between the zinc and copper.
Wala pong
Okay.
chemical bonding pag nasa alloy po.
Yeah, actually hindi if you consider metallic bond, yes, metallic bond is a bond, pero hindi siya type what I mean is hindi tayo makaka-observe ng type of bonding like ionic bond or covalent bond. Okay? Okay. So it's an alloy and metallic bond is present, yes. So we can still consider bronze as a metallic solid. This is correct. Okay?
Nasa na po parang muntik mahulog sa bangin.
Ano ba yung isang naisip mo sana?
Kung hindi po ganun nga, wala po none. If not metallic, none. Kasi nga
No,
po,
actually, well, based dun sa lima natin na categorization, I think lahat ng solid should fall under those classifications. Okay? So wala sigurong solid na hindi natin pwedeng i-classify among those five. Okay? Gallium arsenide, your answer is network covalent solid. Actually, this is correct. Okay. Okay. You are also thinking of metallic type of solid or ionic type of solid. Now, for this case, the bonding between the gallium atoms and arsenic atoms ay hindi metallic. Okay? You can already consider it as a covalent bond, just like the same with silicon. Okay? If you have a silicon material, this is considered as a semiconductor. Meron kang array of silicon atoms bonded together through covalent bond. Okay? Also, it is not an ionic compound. Kasi, well, actually, for this case, medyo tricky talaga siya. Kasi this is borderline ionic and covalent. Okay? Well, to be honest, if you are going...
mahirap po dito, yung mga atoms involved are both metals pa.
Yes, exactly. Tapos, siguro ang ano dito, I'm not sure kung nabanggit na to sa'yo. Kunyari, if you have a compound like sodium chloride, anong klaseng compound to?
Ionic.
Of course, definitely, you can easily say it as an ionic compound. Tama, madali lang yan. If you have another compound like sulfur dioxide, covalent. If you're going to look at the periodic, or if you're going to look at the position of the atoms involved in the periodic table, si sodium nasa metallic side, si chlorine nasa non-metallic side. Tama? Tapos si sulfur and oxygen, they are both on the non-metallic side. Okay? Now, ang idea dito is, imaginein mo, wala naman talagang parang madaling i-categorize si ionic bond at si covalent bond if we are talking about atoms na sobrang layo ng position sa periodic table. Pero kapag lumalapit na yung pwesto nila sa periodic table, lalo yung nandoon na malapit sa line, sa zigzag line, medyo mas humihirap na. Okay? Kasi kung titignan natin, ang covalent bond, ionic bond, they are both bonds in which transfer of electron is involved lang naman, di ba? Ang pinagkaiba lang is yung degree ng transfer. Kapag sobrang laki ng transfer ng electron, na halos lahat ng electron density ay nandun na sa isang atom, like the case of sodium chloride, di ba? Halos lahat na kay chlorine.
Iba na po yung perspective.
Tama.
Opo. Basically po,
ano tinuturo kapag sa Gen Chem, di ba?
Opo. Basically po,
Okay.
an ionic bond is just an extreme strong covalent bond.
Exactly. Parang ganun lang siya talaga. Okay? I mean, in general, if you are going to look at bond, sharing of electrons lang naman yan lahat. Okay? Pero nagkakaiba lang sila ng degrees of sharing. Is that clear? So madaling i-classify if it's completely ionic or purely covalent, 'di ba? Pero kapag medyo nagbo-borderline, yun medyo paano natin i-classify yan, blah blah blah. So for the case of gallium arsenide, parang nandun siya. So for this case, we can classify it as a network covalent solid kasi in a sense, we can still look at the bonding between gallium and arsenic as a covalent bond. Okay? Pero on a different context, pwede mo pa rin siyang i-consider na parang ionic, pero it is a completely different topic. Okay, so depende pa rin sa view, depende kung anong context, depende kung anong application, etc. Pero for this context, yung pinaka-simple, I think we can go with network covalent solid for gallium arsenide. Okay? Sinabi ko lang to kasi common kapag sa Gen Chem sasabihin, ganito yan. Basta ganito, ionic. Kapag ganito, covalent. Pero kung pag-iisipan talaga natin, hindi naman talaga siya basta ganun lang, di ba? Or parang halos pareho lang naman sila. Nagbabago lang ng degrees. Tama? Okay. Is that clear? Nag-make sense? Okay. Good. Letter D. Like for this case, letter D, barium bromide. Tingnan mo, hindi ka masyado nag-worry, tama? You answered ionic solid. This is correct. Kasi if you're going to look at their positions on the periodic table, si barium, madaling i-classify na may metallic property, si bromine, may non-metallic property. And so malaki yung pool ng electron density towards bromine atom. Tama?
Opo.
Hydrogen. I'm guessing kaya ka nagkaroon ng ganitong doubt dahil dun sa discussion natin yung sa molecular orbital theory. Yun ba yung reason?
Ay, hindi po kasi, di ba po syempre po may normal na, pero pag under high pressures po, di ba magkakaroon ng metallic hydrogen?
Yes. Yeah, that's true. Although actually for this context, we are only referring to the normal condition. So just think of this as hydrogen na in order for you to make it solid, i-lower mo yung temperature, for example, or parang just up to the point na magi-start na mag-solidify si hydrogen. Okay? So still, we can look at hydrogen as molecules because naturally it occurs as molecular hydrogen. So if we're going to classify it as a solid, it is a molecular solid. Okay?
Opo.
So actually, metallic hydrogen, I'm not so sure kung anong condition para maabot siya. Like, if can we really make it kailangan ng sobrang sophisticated na instrumentation or something. Okay. Anyway, for radon, if it becomes a solid, this is correct. This is an atomic solid. Okay? Kasi hindi siya nag-exist as a molecule and lang siya, purely single radon atom na pinagtabit na naging magkakatabi lang ng sobra yung form. And aluminum, lastly, this is correct. This is a metallic solid. Okay. Questions? Do you have questions?
Wala po.
Okay. Number 2. Actually, before we proceed with number 2, naalala mo, nung sa discussion natin, I asked you to calculate for the atomic packing factor for a simple cubic crystal system.
Opo.
Okay. So before we answer number 2, can you show me your calculation for the atomic packing factor for a simple cubic unit cell?
Oh, simple cubic. Opo.
Okay.
Ano tayo? 1/4, 1/4, 1/4. Ay, 1/4, 1/8 yan. Ito na po.
Okay. So for a simple cubic unit cell, the atomic packing factor is just equal to 0.52. Okay, or just around 52%. Okay. For this case, actually, we can think of it na parang for a type of crystalline material in which all of the atoms are uniform in size and we assume that they are spherical, ito actually yung parang possible lowest value. Okay. And yung other end, yung extreme, yung pinakamataas na value is 0.74%. Okay?
Opo.
Kaya kung isipin mo yung last time, 'di ba sabi mo for a body-centered cubic structure, the value is around 0.60 something, no? Tama?
Opo, medyo mataas nga po eh.
Yeah. Actually, hindi naman siya sa mataas, pero it kinda looks like na parang hindi siya ganun ka-efficient. Pero if you're going to look at the simple cubic, kahit hindi siya yung pinaka hindi efficient, if you are going to solve for APF, it's still more than half. Okay, that's 0.52%. That's 52%. Okay? Is that
Opo.
clear? Okay. So, ready for number 2.
Opo.
Okay. For number 2, amorphous silica, that's SiO2, has a density of about 2.2 grams per cubic centimeter, whereas the density of crystalline quartz is 2.65 gram per cubic centimeter. So how do you account for the difference in densities?
Ba? Syempre ba kasi yung
More
sa
of ano lang, exploration.
yung sa ice po, 'di ba? Kaya it's more it's less dense than water kasi may mga gaps. So dito rin po parang kung magaganito po, dito mga simplify ko na lang po. Ay, pangit. Parang ganyan po yung amorphous pero yung silica po. Silica po is much more organized, less spacing between the atoms. Ito na po may mga malaking room. Ito po mas maliit.
Yes, exactly. So tama yung term, there's less spacing for the type of crystalline silica, that's quartz. There is less spaces available or pwede nating sabihin, for the case naman of amorphous silica, mas maraming mga spaces na available. And if you're going to go back to the definition of density, density is just the mass per unit volume occupied. Okay? So dahil mas maraming spacing sa case ng amorphous, mas less yung na-occupy ng mga atoms for the same amount of volume. Okay?
Opo.
So basically, yun lang naman. Actually, this question, ano yun?
Opo, so why do glass manufacturers why I haven't seen a single glass manufacturer ever create a quartz, let's say wine glass. Why aren't they making yung quartz po?
I mean, depende sa purpose. Kasi if you're going to make quartz, syempre mas controlled yung manufacturing dapat, di ba?
Opo.
Kasi kung sa glass, hindi naman dapat. So, ibig sabihin, kapag mas may control yung gagawin mo, mas mahirap, that would also add to the cost. So, it depends on the purpose. Like, kung kunyari, kung gusto mo lang naman gumawa ng quartz for window, for example, bakit hindi ka na lang gumawa ng regular na glass? It will serve the same purpose lang naman. Pero for example, sa laboratory, we use quartz glass kasi for a type of experiment like UVV. Familiar ka with UVV spectrophotometer?
Opo.
Ano lang siya, it's a type of instrument that looks into the absorption of material, ng UVV's absorption ng material. Like for example, you have a solution, papadaanan mo siya ng ultraviolet and visible light. Tapos, merong detector sa dulo. Titignan ni detector kung si material ba ay nag-absorb ng ultraviolet light at ng visible light. At kung nasaang wavelength ng light yung inabsorb niya. Okay? For that type of experiment, we use quartz glass. Quartz. Bakit quartz glass? Kasi if it's amorphous silica, nag-absorb si amorphous silica ng UV rays. Okay? So kapag glass lang yung ginamit mo, baka magkaroon ng false positive result. Like for example, lumabas sa result mo, meron siya absorption sa ganitong UV region. Pero yung nag-absorb pala is yung container, yung glass, instead yung solution.
Opo.
Okay? Okay. So, for that case, we use quartz glass para ma-assure namin na yung makita namin na reading ay yung mismong galing lang sa sample or dun sa solution. Okay? So, that's one example in which quartz is being manufactured for a specific purpose. Okay? Okay. Other questions? Do you have other questions?
Ano po?
Okay. Number 3. Ito, this should be quick. Madali lang ito dapat sa'yo. For this case, M is the black ions and yung
Should it be the other way around po? Shouldn't it be the other way around?
Actually, it doesn't really matter. Kasi 'di ba, if you write sodium chloride as NaCl or ClNa, doesn't really matter. But of course, by convention, we always write sodium chloride as NaCl kasi yun yung sanay tayo na na format.
Opo.
Okay? So it doesn't really matter.
Uh-oh. Yeah, okay. Okay. Possibly done. Baka tapos na po. Medyo doubtful po ako dito eh.
Okay na yan? Yan na yung final answer?
Baka. Probably po, yes.
Okay. For this case, sodium chloride and cesium chloride, these are correct kasi pareho naman silang 1:1. For this case, meron kang kailangan na gawin. Actually, for this case, 'di ba tinuro ko sa iyo kung paano siya bilangin. So the goal here is actually not to check if you memorize the formulas, the name, blah blah blah. The goal here is if you know how to count them. Okay?
Apo.
So kung hindi ka sure kung paano, you need to count them. Ano yung magiging formula niya based on how it looks dito sa ano na to, na unit cell na to.
Something is wrong. Or is it right? What? Ah.
Sige lang, kung ano lang yung lumabas sa counting mo. Trust your answer. M2X? M2X or MX2?
Wait lang po. Ano po yung... black circles are X. So, there are twice more pa ng X.
Okay. Final answer?
Siguro po.
How sure?
20%.
Bakit ang baba naman? This is correct. Okay. Correct yan. Okay.
Paano po correct?
Well, you counted the number of atoms, right? First, there are one atom para sa lahat ng corners, di ba? One atom para sa lahat ng corners. And then, for the face atoms, ilan lahat sila?
1, 2, 3, 4, 5, 6. 6 na face atoms, syempre. So, 3 atoms. Tapos,
3. So, for the edge atoms, ilan din lahat sila?
3.
3 din. Kasi there are 12 in total. So, you have to divide them by 4. Tama? Tapos meron pang isang body atom. So, that's how many atoms? 8 atoms in total for the black circles. Okay? And then 4 for M. So, this is correct. Wala yung mali. Do you have your copy ng slide?
Abo.
Kanina siya similar na structure.
Zinc blend.
Now, can you look at the difference? Are they completely the same?
Oh, I see. The edge atoms are missing.
It looks like a similar structure, pero they are not completely the same. Okay? So, for this case, pagkatiwalaan mo yung sarili mo. Okay? Tama yan. Medyo nalito ka kasi akala mo parang, ito yung nasa slides, etc. And then you're trying to come up with an answer na similar with the one na nasa slide. When in fact, magkaiba naman sila. Okay?
Nainis po ako dun sa mga edge atoms.
Okay lang yan. You're doing good, okay? You have to trust your answers.
Trust your answers po. Parang nawalan na po ako ng tiwala po sa judgment ko.
Pero, if you're going to assess it, diba, it turns out, tama yung answer mo talaga. Okay?
Opo.
Okay. Eto. Nag-add ako actually. This is the Perovskite structure.
When I made all of the when I answered all of them, but then may dadagdag pa lang po. May dadagdag pa lang po.
So, okay lang yan. Actually, I thought lang na parang, let's try to do something more na medyo mas challenging. Okay? So, this is the Perovskite
unit. Opo, Perovskite.
Pero shown here is just the unit cell. Okay? So, can you provide me the chemical formula for Perovskite?
Forgar. Wait lang po. FCC 4. BCC 2. Wait lang. Mali pala. There.
So what will be the chemical formula in terms of A, B, and X?
Uh-oh. So B will be Wanda. Okay. B. Two. There are 8 in total. Okay. A, B. 6 of the half. One, two, three, four, five, 6. Those are half. Okay. Ito na po.
Final answer?
Uh-oh.
Yes, this is correct.
Yes!
Okay.
Nakababo ako parang final answer.
Okay, so for the Perovskite crystal structure, the chemical formula is just ABX3. Okay, this is correct. Actually, you can look at Perovskite as a face-centered plus a body atom. Kanina I was thinking na body-centered kasi nung binilang mo dalawa. Pero kapag ganon, kapag sinulat mo body-centered, you're also accounting for the other corner atoms na naka-account mo na dito sa face-centered. Okay? Pero ito you have to remember na what's different from a perovskite. Kung ganito mo siya titignan, you have to remember na hindi lahat ng atoms ay pare-pareho. Okay?
Opo.
Magkakaiba sila. It's an ionic compound. Clear question?
Opo. Ay, wala po.
Okay. So here, number 4.
When the calculations.
So for number 4, ayan, actually at this point, we'll now start with the calculations. So for number 4, sodium metal, atomic weight is 22.99 grams per mole, adopts a body-centered cubic structure with a density of 0.97 gram per cubic centimeter. So A, use this information to calculate for the atomic radius of sodium. So let's go with A first.
Cringe. Nasa middle. Nice. Yes. I'm starting to judge my formula retention.
Don't worry, so far you're doing good.
So far. Keyword was so far. Ayun.
Pero the main goal naman of doing all these practice sets is to make yourself familiarized with all this stuff. Kasi syempre kung titignan natin parang once mo lang naman sila halos nakita nung sa sa initial discussion natin, and now we are putting it into application, diba?
Parang mali yata yung ginagawa ko kasi hindi pala N yung ginagamit. Ay, sira.
Ano yung numerator ng density?
N over NA, which is, this is a number of ano? Face-centered? Body-centered. Okay. What's body-centered? N equals to
kapag ganyan, medyo nalito ka sa formula, always look at the units. Kailangan dimensionally consistent siya.
Apo.
So 'di ba ano yung numerator ng density? It should be mass. So what will be the arrangement of the numbers in such a way na after doing all the calculations, mass yung magiging numerator.
Ay, mole? Nangyari doon. Anyway. Ay, sira lahat. Cell mole. So, nakakansin naman. Cell. Yes, okay, safe. Gram cell. Kailangan ko itong cell. Okay. AO. What is the AO? Ah, it's being looked for. Where did I put the density? 97. Parang mali. Oh, mali.
5.8.
Opo.
2.85.
Parang medyo malaki. Ay, bawal pala yun. Pwede pala. Okay. Parang medyo malaki. Parang laki po.
Oh, okay lang siya. Actually, if you divide this by 100, diba, this is just equal to 4.2856 times 10 raised to negative 10 meter. So it's 4.3 angstrom. Around 4.3 angstrom.
Oh, it makes sense. Kala ko po kasi parang, di ba po picometry ginagamit? Kala
Yeah,
ko po,
okay lang din naman. Although actually for the case of ionic radius, sometimes angstrom, sometimes picometer, depende. May iba-iba din naman na ano. But this is correct. Okay? This is correct.
Opo.
Okay? Questions?
Wala po.
Okay. Actually, yung sinulat mo dito kanina na per cell, okay lang din yun. Kasi dito sa yung volume dito is also per unit cell. Siya yung magka-cancel out doon. But anyway, okay lang din naman.
Hindi
Still
po
come up with the correct.
hindi na necessarily have to cancel out kasi eventually magiging AO per cell.
Yes,
Diba,
yes,
makes sense
yes.
naman po.
Yes. So dun siya. Okay.
Opo. This is the answer in part A. Ha? Parang dumi. Yan. Ayun, kaya pala. Will be close packed.
So for letter B, if it didn't react so vigorously, sodium could float in water. Kasi if you're going to look at density, 0.97 lang siya, di ba?
Opo.
Okay. So it's even less in terms of density than water.
2 square root of 2 over 2. Ay! Ano yung ginamit? Here's going pala. What am I doing? Something is wrong. Kaya pala. Then, so Wait lang. Ba't ganun? Mali.
What's your answer?
Dapat po nasa centimeters na.
Yes.
Pala. Ay, tama pala. Nasa centimeters na siya. Tapos ito, gram.
So, anong answer mo for the density?
Yun po.
1.454. Anong interpretation mo sa number?
5.2487 times 10 to the negative 8 centimeters.
I mean, based on your calculation, your final answer para sa density is 1.454 gram per cubic centimeter, right?
Abo.
Ano sa tingin mo? Is it too large? Is it too low? Or sakto lang? Pwede naman.
Try ko na po itong ito kaya pong, I will plug, instead of doing that, I will just plug in my original, yung original na equation. Kasi hindi po nagmamatch eh.
Match with the original density?
Abo.
Actually, for this case, hindi dapat talaga maging same yung makakalculate mo na density.
Ay, di po. I'm trying to make it, I will plug in the values para, kasi sure na po yung original density eh. It's still not matching for some reason.
Although, ang na-notice ko dito is the number of atoms you put in your equation is 2. Pero for this case, di ba, we are now considering a sodium metallic structure na parang na cubically stacked.
Pagka 2 atoms po over yung ginawa ko po yung original equation. Kaya pala. I found out why.
Okay.
Meron pala akong in-overlook. That was the cube. Ayun, tumama na. Ito may din. Okay, done. Why did I put... Can be. Ayun na po.
Okay. So for your final answer, it's 1.056 gram per cubic centimeter. This is correct. Okay.
What?
Correct. I said correct. This is correct. Okay.
Alam ko pa ba, how did I get correct?
Bakit? Tama siya. Now, if I'm going to follow your calculation, first, di ba nilista mo dito yung relationship between A0 and R for an FCC crystal structure, which is just the same with cubic closed pack. Pareho lang yan. And then, initially, it's BCC. Okay. So, kapag BCC, of course, you have to calculate first for the radius kasi you can't use the same edge length. Of course, the edge length would be different kapag nagbago na yung crystal structure. Pero dahil sodium atom pa din siya, yung dapat na ma-retain is yung radius. Tama?
Opo.
Okay. Tapos, after calculating for the radius, you applied it to the FCC crystal structure to come up with a new edge length. Okay? Tapos yung edge length na yon yung ginamit mo dito to calculate for the new volume per unit cell. Also, you have to be careful. Magbabago din dapat yung number of atoms per unit cell kasi nagbago yung crystal structure. Okay? And so, doing all the calculation, the new density should be 1.056 gram per cubic centimeter. And as you are expecting, dapat yung value niya should be a little higher compared to the original density. Tama? Kasi yung original density is for a BCC sodium metal. Tama? And we know na si FCC is a closed pack structure. Dapat mas mataas yung density niya. Okay? For the answer, siguro quick answer to this question, would it still float on water? We can say no. Okay, it would no longer float. Actually, yung una, that's 0.97, most likely this will float in water. Okay.
So, technically po, if you, let's say po, you apply, let's say, a coating na extremely lightweight naman po, will it float?
If you apply what?
Coating po, para hindi po sumabog. Waterproof.
Pero hindi siya, yung sa BCC na sodium chloride.
Opo.
Ang question dyan is, ano yung coating na pwede nating ilagay? Pero yeah, actually, that's also possible. Pero ang ano dyan, ang magiging consideration dyan, the coating should also not be reactive with sodium. Mahirap yun hanapin. And it should be thin enough para hindi siya yung maging reason kung bakit lulubog yung sodium metal. Right?
Opo.
Okay. Questions? Do you have questions?
Opo.
Okay, okay. Okay, for number 5. So far, no questions,
Wala po.
Okay. So for number 5, lithium bromide has a density of 3.464 gram per cubic centimeter and has a sodium chloride crystal structure. So calculate the interionic distance and compare your answer with the value from the sum of the ionic radius found in the appendix.
LIBR has an NaCl. Okay. So, what? Darn. Wait. Is it possible to use it po kahit na hindi po same yung ions?
For this case, go back to the equation and then try mo siyang i-analyze term per term. So before you substitute the numbers, can you please write down first the working equation for density? Yes.
What is the volume?
Sorry, what's this? Ano ba?
Sabi mahanap po. Okay, hanapin ko na po yan, ASAP.
Okay.
Hindi,
ano lang muna natin, analyze lang muna natin yung equation. So for this case, di ba, density is equal to mass over volume. And based on our calculation, what we have, yung parang general form natin is, okay lang ituloy ko?
Abo.
This is equal to N over NA times the molar mass over volume. If it's cubic, it should just be equal to A naught cube. Tama? Now, for this case, yung number of atoms na so far ginagamit natin is just 2 or 3 or 4, blah, 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 for BCC and FCC. The difference for this situation, we have an ionic compound. This is lithium bromide. Tama? But if you are going to look at the unit cell, tingnan natin yung unit cell. At kung i-apply natin yung idea dito sa density, di ba density still just refers to the total mass of the unit cell over the total volume of the unit cell. So kahit na magkaiba yung laman niya, pwede pa rin ba nating makuha yung total mass?
Yes, molar mass.
Yes. For this case, kailangan nating i-account kung ilan yung bilang ng lithium at kung ilan din yung bilang ng bromine. Tama? And sila yung dapat sila yung nakamultiply respectively doon sa molar mass nila. Okay? So parang magiging ano lang to. Pwede natin siyang gawin na N lithium over Na times molar mass of lithium plus N bromine over Na times molar mass of bromine. Tama?
Abo.
Okay. You want to draw it as a point model, okay lang din.
Nagkana po. What next? Well, there's much more. Bro. This is literally cursed. Tsaka po, is it, okay, I see.
So, sige, gawin natin step by step. First, ilan ang lithium atoms per unit cell? Ilan ang bromine atoms per unit cell?
I will just use the NaCl structure instead of trying to draw it. I just realized meron pala po sa kabilang page po. Ano yung Na dito? Na is M. So, X somehow. 8 times then BR okay, 4. I just realized that was actually the FCC and I didn't have to calculate. Bro, why did I do that? And L.
Okay lang yan. Para mas sure actually. So, okay lang din yan.
Na-realize ko po pero pala pong FCC na nakasulat, bro. LI 6.94. BR. May lang. Dalawa pala ito. Parang amoy sunog, daddy. Okay. Ayan. Sunog. Ayun. Yun na po.
Okay. For this case, nilabel mo siya as T sub I. So I guess you're referring here to the sum of the interionic distance ni lithium tsaka ni bromine. Tama? Kasi kung titignan natin yung side ng lithium, di ba kung meron tayong lithium bromide na crystal structure, just NaCl, yung side is just equivalent to, di ba meron ka dapat isang atom dito ng, tapos isang, kung
Ganyan po na.
tama. So this is just equal, so A naught here just equal to 2 times the sum of lithium radius plus bromine radius. Tama?
Aba.
A naught is just equal to 2 times radius ni lithium plus radius of Actually, lithium ion and bromide ion. Okay.
Aba.
So I assume itong DI here is just equal to the sum of the lithium radium. Oops, sorry.
Kita ba?
Yes. So, do you have your copy nung sa appendices?
Aba.
Okay. Can you look for the radius, ionic radius of of lithium ion?
Electron affinity radii. Ayan, radii. Radii. Li. Ionic radius 76. Ay, mali ko nalagay. 76.
Unit. Picometer?
VR. Ay, naka-Armstrong pala.
No, it's fine. Okay lang.
Di po.
Sige.
Point 76.
Okay.
Baka magulo po kasi ako, parang ang laki.
Oops, you still wrote PM.
Ay, PM pa rin. Bamboozle. Okay. Saan yung VR? Nawala. Ayun, VR. Covalent radius, ionic radius.
Ionic. Look for the ionic radius.
196 yata po. Di ko lang. I can't see it well.
Sorry. Hindi ba malinaw yung copy? What's the sum?
Ganon. So,
sorry po, hindi pa na-print yung mas malaki po. Sorry. Ito, Jones, may mag-define.
Sige, okay lang po.
ilan po?
Binigyan ko po siya ng mag-define glass.
Ako po, kaya ko makita po yung pinakamalit. So, pag wala po akong hindi ko po makita, sabihin, sobrang liit na po. 196 na. Huh?
What's the sum?
Bro?
0.72. Based on our answer, based on the density value, we have 2.75. Based on the tabulated value sa libro, it is 2.72. And this is actually correct. Okay? And kung titignan mo, based sa estimation, we're actually pretty close. Kasi most likely, yung mga tabulated values, yung mga values na yan is obtained through some other experimental data. Okay?
Opo.
So, there are basically many ways to solve for this depending on kung anong technique yung gagamitin. Okay? Questions? Do you have questions?
Wala po.
Okay, just remember lang for ionic compounds, always remember na yung for the density calculation, you need to split the mass terms into two terms or even more, depende kung ilan yung laman ng unit cell. If it's a two-component unit cell or a three-component component unit cell even. Okay?
Meron pa pong mas mataas pa po nun?
Well, yeah, that's also possible. Especially for kunyari. Pero most likely parang may observe mo lang siya para sa mga specific type na ng researches. Okay.
Opo.
Ayun. Example ng 3 kanina nakita mo, that's a Perovskite structure. Okay.
Meron mo pong parang perovskite pero na-occupy lahat po yung edge, tapos may na-occupy na rin po yung tetrahedral octahedral. Lahat lang po na-occupy. Pero iba-iba pong atoms po yun.
Parang medyo ano na yan, mahirap siyang makita in nature, pero kung gagawin mo siya, i-synthesize mo sa lab, pwede rin naman siguro, pero mahirap siya. Kasi 'di ba, tawag dito, parang if you are expecting yung ganong klaseng combination tapos sobrang ordered nung structure, medyo mahirap siya. Kasi ang goal ng environment is randomness, 'di ba?
Opo.
Okay. So shall we proceed to number 6?
I've lost track of how many atoms I've counted. Opo.
Actually, sa mga more complicated na mga ng mga structures, is very useful to use advanced softwares for the computations ng mga ganito, ganyan. Even the energetics actually, yung mga calculations ng band gap, ganyan, you can do that through simulations. Pero yun naman ay simulations lang. They're just trying to look at the possible interactions among the molecules using by solving the Schrödinger equation, blah blah blah, mga ganon. Pero still yung best way pa din to get a more accurate value is to do the experiment. Okay?
Opo.
Number 6, ready?
Opo.
Okay. So clear lang muna natin. Okay. For number 6, iron with a density of 7.86 gram per cubic centimeter crystallizes in a BCC unit cell. BCC unit cell at room temperature. So calculate the radius of an iron atom in this crystal structure. Okay. At temperatures above 910 degrees Celsius, iron prefers to be FCC. So if we neglect the temperature dependence of the radius of the iron atoms on the grounds that it is negligible, we can calculate for the density of FCC iron. So use this to determine whether iron expands or contracts when it undergoes transformation from BCC to FCC structure.
So sabihin nga po dito yun sa core po, di ba? Mag-iba. Pag nasa core po.
Yes.
Ayun.
Well, actually, core sobrang iba na rin ng temperature. And most like, may mga cases na hindi na siya solid. Nag-liquefy na siya.
Pero nga po yun sa inner core po, solid po yun.
Hindi ko lang sure kung ano yung temperature. Pero for this case, yung working range lang, yung temperature lang natin nasa 910 lang degrees Celsius. So, hindi ako sure kung magiging FCC pa din ba siya or baka iba na yung crystal structure. Pwede din yun.
Are there any restrictions to what a metal or ion product? No, hindi pa. Are there any restrictions on what a metal cannot be? Kumbaga po, is there a restriction that iron cannot be HCP? Or wala po?
Actually, kung isipin natin, parang wala naman. Okay? Pero so far, ang sinasabi ko lang sa'yo ay kung ano yung na-observe in nature. Okay?
Apo.
Although, kung si iron, about the possibility of iron also existing as HCP, I'm not sure. Pero possible pa din naman. Pero kung existence niya in nature,
It's
not really sure. Pero there is a lot more possibility lalo para sa para sa combination ng pressure and temperature, tama. So if you just play around with a right temperature and pressure, you can definitely make an iron with, let's say, HCP crystal structure, etc., etc. So it's a question lang ng ng pag-control nung condition.
Apo. Bro, I forgot.
85 yata, tama ba? 0.85.
When I
0.845.
finally got the the periodic table, so now everything's much more accurate. Ay, nalipad.
Actually, for iron, tandaan mo siya, it's always 55.8. Actually, ako nasanay lang ako gamitin 55.85. Medyo tricky kasi yung yung tawag dito yung molar mass ni iron. Minsan kapag ginamit mo 56 or yung iba may mga ganun, so parang medyo mas lumalayo yung answer.
Opo.
Naalala ko na, ang mas tricky pala si chlorine. Kasi chlorine is 35.5 around that value. 35.45 din yata, parang ganyan.
Opo.
Kasi if you use 36, medyo mataas. If you use 35, medyo mababa naman. Parang may ganun eh.
Opo. Kaya pala naka-picometers. Ay, hindi, naka-centimeters na sa baba. The radius of the atom does not change. Okay.
Yes. Always remember that, okay?
Kala ko po parang lalong variable. FCC. Even necessary? Necessary ba po to? Kasi technically it's not necessary anymore.
Yung alin ba? Yung alin?
Ito po, pag ganito po, if I turn 2 into 4, then it will the 7.86 will double.
For that case, hindi mo siya pwedeng basta gawin lang kasi magkakaroon ng difference dito sa A0. Tama? Kasi iba yung A0 if it's FCC, iba rin yung A0 kapag BCC. Right?
Kaya pala, bro? Radius pala, hindi ko pa nakuha yung radius.
Yes.
Therefore, radius.
So, hindi siya basta multiplication lang by 2. Right?
Apo.
Okay. Is this your answer for the new density?
Abo.
Okay. So how do you interpret the values? To answer the question, use this to determine whether iron expands or contracts when it undergoes transformation.
Therefore, it contracts kasi it actually makes sense din po, diba? Mas ano po yung atomic packing factor. So,
yes. Actually, yes. Even without calculating for the new density, you should be able to easily say that we are expecting iron to contract if it transform from BCC to FCC. Tama. Pero just to make sure, and actually the main goal naman here talaga is to check whether whether the values we have actually is consistent with what we have in theory. Okay? So far, okay naman siya. Okay? The BCC density is 7.86 and the FCC density is 8.56. So this is correct. Okay?
abo.
Question.
Wala po.
Okay. Number 7. Ito medyo actually same lang din to. This is just the same type of calculation pero medyo iba yung approach. So for number 7, a metal is found to have a BCC structure and a lattice constant of 3.31 angstrom and a density of 16.6 gram per cubic centimeter. So propose an identity of the metal.
Ito nga po is, this is kung meron po kayong ano po yung density po na ano, madali na po kasi halos unique po yung mga density. I instantly ko
Pero no. Pero no. You have to find another way to have an identification of the metal. So paano mo siya gagawin?
I know. The atomic mass. Easy.
Yes, exactly. So for this case, sabi lang naman, it is a metal. So pure substance siya.
How do you know po kung pure? Kasi,
A metal is, well, yeah, actually, it can be an alloy. That's true. Pero let's work on the assumption that it is a pure substance.
abo.
Well, actually, kung ano to kung inisip ko tuloy, kung ano siya, kung chemical analysis siya, like for example, you work in a lab, tapos binigyan ka ng isang substance, can you please identify the metal? Tapos you are a material scientist, let's say. Tapos yung based sa mga gamit na meron ka, you can get the lattice constant, you can get the density, but you also have to also check the purity of the substance. Well, in analytical chemistry naman, there's a lot of methods to check kung pure metal ba siya, etc., etc.
When the calculator says cannot solve, bro, I have to do it on my own. Ayun. Done.
Actually, may technique kapag nag-cannot solve siya. Cannot solve yung ano are you using the solver function, yung shape solve? Ginagamit, yun ba yung ginamit mo? Okay.
Tapos ang calc.
Actually, ang technique ko dyan kapag naggaganyan, I just rearrange the number in such a way na yung form niya ay x equals the bunch of numbers. Kasi mas kaya niya yung isolve. Although, well, yeah, actually, most of the for me, ito opinion ko lang. I think for this type of equation, hindi magandang gamitin si shift solve. Kasi for that reason, especially for kunyari contest. Kasi before nung sumasali ako sa contest, kailangan ma-analyze mo din kung yung equation ba ay magandang isolve sa shift solve or hindi. Kasi for this case, one variable lang naman siya. The only variable you have to solve is the molar mass. Tama?
Opo. I found out why ayaw po mag-shift solve.
Bakit?
Hindi ko po na-convert from angstrom. This is my classic mistake.
That's fine. Sige, ano lang, just be more careful. Well, actually, mas okay to. Mas okay na, na nakikita mo yung mga kung saan ka nagkakamali. Kasi this means na in the future, malalaman mo na, ay, dapat ganito, ganyan, ganyan. Ganun ako dati, before when we were, joining a contest. Meron kaming, sinasalihan na contest ng college. Yearly siya. Tapos chemistry contest siya. So of course, we also do preparations. And aside from reviewing the topics, inaaral din namin pati kung paano mabilis gamitin yung calculator, mga ganyan. Kung ano yung mga technique para ito na lang yung gagawin instead of ganito, ganyan. So sa ganito, kunyari nakikita mo, nagkamali ka dito, it's actually a good thing kasi in the future, malalaman mo na, dapat hindi ko to gawin. Right? Kaya for this example, don't get frustrated kapag kunyari nagkakamali ka sa pag-solve sa ganito, ganyan. It's fine. It's actually part of the process.
When the shift solve finally works po.
Ano yun?
When the shift solve finally works.
That's good. Okay. So the molar mass is 181.
My job now po is just to find out which matches it perfectly. I know po this is tantalum, but from my data, actually the closest talaga po is tantalum, but it's either tantalum or tungsten. Pero
okay, what is molar mass of tantalum and what is the molar mass of tungsten?
More specifically po, yung nakasunod po dito iba yung iba pong structure. So yung alpha tantalum.
No, molar mass lang naman siya. So kahit magbago yung crystal structure, the molar mass should be the same.
Tapos sa W. I didn't say W.
So what's your final answer?
What osmium? Rhenium. Malayo. So the most possible answer is, I'm afraid, tantalum. And that's it. Kasi yung density na po, nakasulat po naman dito, density. These are tantalum.
Yan, for that case, density, importante yung crystal, yung phase. It would definitely change. We also have the data for density, yan.
And then, the ultimate distinction. So, it is now very, very, very clear that it's tantalum and not tungsten.
Okay. Good. Very good. Okay. Actually, for this case, if you told me that the answer is given a limited information, if you told me kunyari exam to tapos limited lang yung information, like you are only given the periodic table with the molar masses. If you answer tantalum and tungsten, it would be fine for me. Kasi the goal of the scientist naman is to eliminate possible information eliminate possible answers based on the information that we have. Pero for our case, you also have the data for the density. So
So,
yes,
so
we
yun
can
nga.
rule out gangsten.
Opo, pero ginawa niyo po, you assumed it was tungsten. So now you placed a corrosive acid. But then it turns out it dissolves tungsten. So now you're doomed.
Okay, question. Do you have question?
Wala po.
Okay. Number 8.
Easy. Hopefully.
Nice. So for this case, calculate the lattice energy of calcium chloride given all the data in kilojoules per mole.
Yes. Both of them are in their, I forgot the name. Their,
Elemental state
and they are all both in their elemental state.
or reference form.
Sir, pa-animate ko lang po si Josh.
Yeah, sure po, sure po. Actually, I forgot. Nung mga nakaraang session din natin, I forgot to give you kahit mga 10-minute break din. Actually, Joshua, if for example, gusto mo mag-break for a while, okay lang din naman. You can just tell me.
There is something wrong. Where is the... Oh no.
What is
Where is the gaseous, where's the melting?
Off?
Yung calcium po, wala po yung melting. Oh no.
I think meron akong...
Each VAP is missing. Wanted, each VAP alive.
Oh, sublimation yan na. Hindi siya vaporization. It's from solid to gas. Bakit ganun? Saan ko na double check ko na yung values na. Pero you have your copy dyan, no? Can you please look for the voltage sublimation for calcium?
I don't think I have sublimation. Is there po a table? Meron po table in sublimation?
Atomization is the same with sublimation.
Ayun.
Kasi diba sa sublimation, you have the solid structure. Kapag naging gas, hinihiwa-hiwalay mo lang naman yung mga atoms, diba? In such a way na halos wala na silang interaction.
Atomization. Well. That's not dissociation. Or is it? Technically, it's supposed to. Yes, it is. Anyway. 176.
For that case, whether you call it dissociation or atomization, okay lang din. Kasi for the case of chlorine, aside from breaking the interaction among the chlorine molecules, you also have to break the bond between single or among single chlorine molecules.
Abo.
So pareho lang din naman yun.
Kung gagawa po kayo ng parang periodic table po, lagay nyo, kung pwede pong parang isang malaking isang malaki pong paper, oh. Tapos ng lahat po ng possible information.
Gusto mo ng ganung periodic table? Although, I'm not sure kung merong ganun sa sa internet. Unless you want to do it on your own. Parang
Yung web elements
Pero
po, meron siyang malaking periodic table. Tapos lahat mo nandun. Dapat ma-print ko yun. I don't know the value. Anyway. May po? May CAF2. Tank. Yao died. Negative 795. Okay. EA. Technically, are these still gaseous or are they not? They should be plasma.
yung alin?
Yung Cl
Yung alin?
Yung Cl minus po.
Well, for that case, kasi pwede naman. I mean, it doesn't really matter if you write down. And actually, for that case, yeah, dapat ilagay mo siya gaseous form. Kasi, for the case of, let's say, sodium chloride, chloride by itself is an ion, tama? Pero nasa solid structure siya. So, contained yung chloride ion. For this case, we are looking at a chloride ion na walang interaction with other ions.
Abo. Wala rin po yung ionization energy of calcium. Ay, wala pala. Wala talaga.
Bakit hindi ko nailagay yung I'm so sorry, hindi ko na-provide yung Pero can you look for it dun sa table ulit? Nandun siya sa meron din dyan na ionization energy.
Lahat na po nilagay
Kasi,
sa table. Okay.
I'm sorry, kasi kapag kapag nag-minimize ba ako, baka mawala yung sinulat mo. I'm not sure.
Hala.
I'll go alt tab.
Nawala po yung sinulat.
Nawala?
Ay, hindi po. Nandun pa rin. Hopefully.
Naka-slideshow view pa din ba ako?
Abo. Hindi po. Nasa parang may ganun. Naka-dash. Siguro po yung parang black. nahanap ko na po. Calcium.
Ito, naka-slideshow view ako.
Abo, naka-slide na po. I found it.
Kapag nag-alt tab ako. Ito, naka-slideshow view pa din.
Abo. I eat. Kaya pala. I just realized. It needs 2 IEs.
Kapag ganito, wala naman nag-obstruct sa view, Joshua. Kasi nag-open ako ng ibang ano.
Meron po, yung parang black.
Like on the middle ng screen. I see.
Nahihirapan po ako mag-align ng data.
Sorry. Ano ba yan? Yung sa copy ng slides? Or ano?
You want to check on the Google Slide, Drive? Yes.
Kasi pag isang mali ko lang po, 1521 yung sa taas, tapos 418 po eh. So talaga, hindi malayo po sila.
Ito yung drive, Open. TikTok kayo.
Ayan, nasa phone po.
So for calcium, it's 100. Ay, wait lang. Sorry. Ionization energy pala, no? Ionization. For calcium, it is... Here is calcium. 500... Yung 500 something. 589. 418 is for potassium. 589.8. That's for the first ionization. Second ionization is 1145.
Wala.
So it's 589.8 and 1145.
Ayan. 5.8. Hindi ko na po makita. Ayan. 5... what is this? IE2. 11. Oo, 11. What? Oh no, I forgot.
1145.
Ayun, abo. We should done. We should be done. Okay. Tang! Nag-mirror sa mali. Ayan. Done. Taas!
Yes, it is.
Grabe! Is this even possible? Mega joules! Nakita ko lang po ito yung mga megajoule sa mga, yung mga, let's say po, ammonium nitrate explosion.
Actually, kapag mas mataas pa yung charges ng ions, mas mataas lalo ang lattice energy.
Grabe, abo.
Okay, so your final answer is negative 2,251.8 kilojoules. Always remember yung per mole. Huwag mo siya kalimutan. Just to emphasize na yan ay per mole ni calcium chloride. Okay?
Abo.
So I think master mo naman na natong Born-Haber cycle. Do you have questions about this?
Wala po.
Okay, good. Actually, sorry, I included so much data na hindi naman kailangan. Pero yung mga kailangan, hindi ko na ilagay yung iba.
Parang nga po, hindi ko alam po, parang, nung nakita ko po yung una pong slides, ano ba po, 3 question ba po yung, 3 question ba po ito? Ba't po may mga calcium?
Actually, the purpose is to actually, put some other data na hindi naman talaga kailangan. Pero, turns out, may mga nakalimutan pala ako. Anyway. Question.
Wala po.
Okay. And actually, this is the last question for the practice exercises. More of descriptive type lang. Pero I also want you to
when the last question is not the hardest. Yes.
So using band structure of solids, explain the difference in conductivity of intrinsic semiconductors, P-type semiconductors, and N-type semiconductors. Also mention the major charge carriers.
Hey, I could use the Zoom tools. The Zoom has its built-in. Genius.
Ano siya?
What about this? Genius pa rin. Yes! I found the way. Invisible. Forgar. I realized it should be the other way around. I have to do everything all over again. Why?
Yes, actually, ayoko munang sabihin. Gusto ko na gusto ko na ikaw yung maka-realize.
Ako po yung nakaisip po ako ng great idea. Hindi po. Feel ko na lang po. Oh no! What do I do? Please! Don't erase! Yun! Thank goodness. Oh no! Oh no! Don't erase, don't erase, don't erase.
Ayaw niya.
Yun!
Wow.
I have found, instead of doing everything all over again, I can finally manipulate it. I can just erase. Oh no! Make it small as possible. Uh-huh. Epic. Okay, so what happened? Uh-oh. Lag. Okay. Okay na. Then I have graduated in graphics design.
Okay, yan na ba? Final? Yan na yun?
Ila po. So, major charge carriers. What's this? The acceptor and this the donor. No! Forgar. Valence band. Ayun, valence. You know what? I will just to keep it cool. There.
Awesome.
Graphics design. Okay, so this looks good already. What else? I don't think that's the EG. Yeah, I don't think that's it. Technically not.
Yeah, correct. Correct yan. That's still the value of EG. Well, sige, tama rin naman yung naisip mo technically. Pero in a simple, for the simplest case, you can label that as EG. It's fine. Pero syempre, may iba pa talagang usapin pagdating sa actual na band gap energy for other types of semiconductors. Pero if you're going for the simplest case, tama yan. Anything else to add?
If sinabi pong anything else to add, it means something is missing. I know po from experience na something is missing.
Pero sometimes I ask the student if the answer they gave me is their final answer. Kahit na tama naman yung answer nila. Sometimes gusto ko lang ding i-check
I
yung
am
conviction ng students.
I am still doubting myself po lalo. It makes me even more nervous to say something kung parang are you sure po? Oo.
Kaya okay lang yan. Actually, I want you to be more assertive. I mean, if you think that tama naman, then iyan na siya, i-defend mo siya. Trust your answers. Siguro ito na lang.
There, yun lang po yung pinaka
charge carriers.
Mention the major charge barriers. What are the major charge barriers, bro?
Carriers.
All carriers.
As in the carrier of electricity.
This one, electrons, literally. Major charge carriers. And major charge carriers. What gives them the charge carriers? Oh, okay. So this is before I place it too high. What else? Charge carriers. What gives them the charge? Gives them the charge. Oh, this one's the lack of electrons. Okay.
And what do we call them?
Holes, okay.
Yes.
I realized that after like 15 minutes of brainstorming.
Still, the good thing is you came up with a realization.
Bright light. Ay. Right, H prime.
Yes.
Yes.
Okay. Anything else to add?
No. This makes me... Hala. Meron pala.
Or if you're going to look at the direction, meron pa bang na-miss? Wala naman na. Using the band structures of solids, you just have to explain the difference in conductivity. And so far, based on your illustration, okay na ba?
Mention the major charge carriers. Check. Okay. Explain the differences in conduct. Yeah, okay. So this still has a wider gap and this has a... Oh no! I ruined it! Oh no! Okay, this is like a big brain time.
Or maybe, you can think of it as an electron na, 'di ba, wave functions naman sila. So, hindi naman talaga definite yung boundary. It's really,
Opo.
wow, naayos pa din. Okay. So, is this your final answer? Actually, this is more than enough.
Opo, this is the
Para,
probable
kasi,
final answer.
he also gave an example, although hindi naman na siya tinatanong sa question. Although ito lang for this case, I think
Pang-textbook na po
best,
to.
I think it is best if you write down arsenic doped silicon or gallium doped silicon instead of doped arsenic. Kasi yung main material is not arsenic. The main material is silicon. And then the impurity that you add is either arsenic or gallium to make it N-type doped semiconductor or P-type doped semiconductor. Right?
Para wala pong butas.
Clear?
Opo.
And then one last thing. Normally, if I write down a band structure, mostly binabaliwala siya. Pero ako personally, gusto ko lagi may nakalagay sa y-axis na E. Just to specify that these are actually bunch of energy levels. Okay?
Opo. So, just para matapos na po.
Wow. Okay, sige. Buburahin ko yung akin kasi nakakahiya dun sa arrow.
Ha. And then, it is done.
Okay. Good. Questions? Do you have questions?
Wala po.
Okay. Actually, kung wala, that actually ends our discussion for solid state chemistry, for the chapter on solid state chemistry. Okay.
Kumusta po, sir, kumusta po si Joshua?
Pangit daw po.
Hindi ako nakaupo kasi ina-ask mo yung mami. I needed to do something here. Tsaka, hindi ko kasi siya na-supervise eh. I went out to buy from the market.
Okay naman po, sir. Actually, sobrang smooth lang po ng ng pag-solve namin sa mga problems.
Pero pong dot po dito eh. Ayun, inayos.
Actually, naman po, almost all of the questions, pagka-flash ng question, alam niyo naman na po agad yung gagawin eh.
Apo.
And, ang comment ko lang, Joshua, trust your answers. Minsan kapag tinanong ko lang, is that your final answer? Magda-doubt siya kagad, did I do something wrong? When in fact, tama naman po talaga yung answer na binibigay niya.
Thank you very much po. Thank you for
Yes,
teaching very well po.
Ito po yung final na pang textbook na po to.
Okay. Gusto niyo publish? Okay. Thank you, Joshua. And for the next discussion, I'll coordinate siguro po muna with Sir Melvier kasi parang he mentioned na after this chapter, magkakaroon po yata muna ng parang sort of comprehensive exam. Parang ito po yata yung last chapter.
No!
Okay.
Although, I'll coordinate po muna with Sir Melvier.
Okay po, sir.
Okay. And actually, Sir Jay, if okay lang, kasi I'm not sure po with the Thursday session if I can commit. Kasi meron po akong final presentation on Monday. So parang medyo kailangan ko lang po mag-prepare.
Sige po, okay lang po.
For my class.
Okay lang po.
For my class po in Japan.
Para start na rin siya na review for the, if ever, from the mga previous chapters po.
Sige po. And I'll ask din po, Sir Melvier, coordinate na lang po. Tapos maybe we can, na lang po, send messages through the messenger na lang po.
Okay po.
Apo.
Sige po, thank you po.
Thank you so much po. Thank you so much.
Thank you po.
Joshua, good job. Thank you, thank you.
Have a nice evening po.
Bye-bye po. Thank you po.
Okay, so kung wala nang questions, sige, I'll end the discussion na. Thank you, thank you.
Thank you po. Bye-bye po.
Bye-bye.